Wildcat. Today we're going to Wednesday, April 3rd, solve exponential and logarithmic equations part 1. This will be on page 68. If you would, update your table of contents. Now your table of contents are updated. Let's take a look at the notes. Solving exponential and logarithmic equations, page 68. Solving exponential equation methods. Method 1, graphing. Method 2, same base. Method 3, take the log of both sides. Solving logarithmic equation methods. Method 1, make an exponential. Method 2, use log properties. If you would, update your notes. Now your notes are updated. Let's take a look at the examples. All right. So here, the bases are the same. When the bases are the same, the exponents are equivalent. So that's x squared equal to 7x plus 12. Now we're going to subtract 7x and subtract 12 from both sides. So you have x squared minus 7x minus 12 equal to 0. Now at this point, you're going to factor. So we need to find all the combinations to make negative 12 and combine to be negative 7. So 1 times negative 12 is negative 12. 1 minus 12 is negative 11. That didn't work. 2 times negative 6 is negative 12. 2 minus 6 is negative 4. That didn't work. 3 times negative 4 is negative 12. 3 minus 4 is negative 1. Those didn't give you negative 7, so this is not factorable. Okay, so we have to use a quadratic formula. So x equals negative and negative 7, so it's a positive 7 plus or minus the square root. And actually, let's go ahead and do some of the work here. So 7 plus or minus the square root of negative 7 squared minus 4 times 1 times negative 12 divided by 2 times 1. Well, negative 7 squared minus 4 times 1 times negative 12 is 97, and then divided by 2. Now, at this point, let's go ahead and find the x values as decimals. So control divide. 7 plus control square root of 97 divided by 2. Enter. Highlight, enter, change the plus to a minus. And so let's round one decimal place. So we have 8.4 and negative 1.4. Now at this point we need to check. Now we're checking 8.4, but when we check it, we actually have to plug all of this into the equation, okay? So let's delete this. So we have 2 raised to the parentheses, control divide, 7 plus control square root of 97 divided by 2 squared. Okay, I'm going to highlight, enter. Well, no, I'm sorry. I'm going to put in the right side. So 2 up key, 7 parentheses, and then, nope, I can't highlight that. So I'm going to have to type it in again. So control divide, 7 plus control square root of 97 divided by 2 plus 12. You can see here that they're both equivalent, so this checks. So 2.3 equals 2.3, so this checks. Now let's check x equals negative 1.4. So to do that, we can actually use the work we already have. Highlight. Let me see if I can darken this a little bit. There we go. All right, I'm going to change the plus to a minus. And I'm going to highlight this, press enter, change the plus to a minus. There we go. So you can see they're both equal to 4.08, so that checks. Okay, now let's take a look at example 2. These don't have the same basis, so we need to make 8 with a base of 2. So that's 2 to the 3x equals 2 to the x plus 6. Now, the bases are the same, so we can say that 3x equals x plus 6. We're going to subtract 1x from both sides. You get 2x equals 6. Divided by 2, x equals 30. Okay, so let's check. So check x equals 3. So 8, so we did this, 8 to the third power equals 2 to the 3 plus 6. So they both equal 512. So this checks. Let's take a look at example 3. All right, now here they have the same base, log base of 4. So we can say that x squared equals negative 7x plus 4. So we're going to add 7x to both sides and subtract by 4. X squared plus 7x minus 4 equals 0. Now, there's no numbers that multiply to give you negative 4 and combine to be 7, so this is not factorable. So now let's use the quadratic formula. So that's x equals negative 7 plus or minus the square root of 7 squared minus 4 times 1 times negative 4 divided by 2 times 1. So 7 squared minus 4 times negative 4 is 65, which has this x equals negative 7 plus or minus the square root of 65 divided by 2. Now, there's no perfect square that will multiply to give you 65, so we are set with this answer. But let's go ahead and write the answers as decimals. So x equals and x equals. So to do that, we're going to use our calculator. So control divide, negative 7 plus control square root of 65 divided by 2. And then highlight enter, subtract. So x equals 0.5 and x equals negative 7.5. Okay, so now we're going to check. But remember, we can't put the decimals in. We have to actually put this into the original problem. So it gets a little messy. Let's go and do it. So control log base 4 of parentheses control divide negative 7 plus control square root of 65 divided by 2, and that's squared. And then control log base 4 of negative 7 parentheses control divide negative 7 plus control square root of 65 divided by 2 plus 4. You can see that negative 0, oh, and actually before I write that, that was checking, which one was that? That was the 0.5, so x equals 0.5, so negative 0.9 equals negative 0.9, so this checks. Okay, so now all we have to do is highlight, change the plus to a minus, and then highlight this, change the plus to a minus, and we can see that x equals negative 7.5 checks because 2.9 equals 2.9, so it checks. Okay, so go ahead and finish up example 3. All right, now let's take a look at example 4 and 5. It says solve the equation by taking the log. Okay, so what we're going to do is we're going to do log base 3 of 3 to the 2x equals log base 3 of 25. Now we can do that because of equality. What we do to one side, we do the other. Now this becomes power of 1. This becomes 1, so you get left with 2x equals log base 3 of 25. I want to divide both sides by 2. So let's go ahead and do that. So control log, actually before I do that, control divide, control log base 3 of 25 divided by 2 is 1.46, which we can say is 1.5. Now, it would be nice to be able to just plug in 1.5 to check, but I'll show you why we can't do that. Okay, so if I were just to use 1.5, then I'd do 3 upkey 2 times 1.5, and it equals 27. So it would, if you did it that way, you would say it wouldn't check. So what you have to do is 3 upkey 2 parentheses, control divide, control log base 3 of 25 divided by 2, and you can see that it checks with 25. Okay, let's take a look at example 5. So we're going to do log base 5 of 5x minus 2 equals log base 5 of 200. That becomes 1, so you're left with x minus 2 equals log base 5 of 200. You're going to add 2 to both sides, so x equals log base 5 of 200 plus 2. So x equals, and let's put that in the calculator. So control log base 5 of 200 plus 2 is 5.3. Okay. And again, we'd love to just check with that number, but we're going to have to plug all of this in to check for x equals 5.3. So to do that, we're going to do 5 upkey control log base 5 of 200 plus 2 minus 2. And you can see it's 200, so 200 equals 200, so it checks. Okay, let's take a look at example 6 and 7. Solve the equation by using log properties. So here, we know by the properties from our notes, from I think the previous lesson, that this is log of 45x divided by 3 equals 1. So now we need to raise both sides. Now, almost forgot. Let's go ahead and simplify this. Now, if there's not a base, let's make base 10. So this would be log base 10 of 45x divided by 3 is 15x equals 1. Now, what we need to do is we're going to raise both sides by 10. So we're going to raise this by 10 and this by 10. Well, 10 raised to log base 10, this becomes 1. So you're left with 15x equals 10 to the 1 power is 10. Okay, divide both sides by 15, so x equals 10 divided by 15, which reduces to be 2/3. Okay, so we're going to check x equals 2/3. So to do that again, we're going to use our calculator. So we're going to do log, and again, base 10, 45 times 2 divided by 3 minus control log base 10 of 3 equals 1. So it checks. So 1 equals 1. So it checks. All right, let's take a look at example 7. All right, now when it's plus, it becomes multiplication. So this would be log base 10 of x times x plus 9 equals 1. Again, we're going to raise both sides by the base of 10. This becomes 1. You get x squared plus 9x equals 10. We're going to subtract 10 from both sides. So you get x squared plus 9x minus 10 equals 0. Now, this factor is easy because they make negative 10. There's really only one combination they could use. X plus 10, x minus 1. So he said x plus 10 equal to 0, x minus 1 equal to 0. So subtract 10 from both sides, x equals negative 10. Add 1 to both sides, x equals 1. All right, so let's check x equals negative 10 first. So again, we're going to utilize our calculator. So let me delete this. So control log base 10 of negative 10 plus log base 10 of negative 10 plus 9. You see you get an error. So error does not equal 1. So that we could say negative 10 is an extraneous solution. And we can abbreviate EXTSOL. Okay, so now let's check x equals 1. So I can use the same thing here, and I'm going to change the negative 10 to 1 and change this to 1. You see that 1 equals 1. So this checks. So x equals 1 is the solution. All right, let's take a look at example 8. Solve the equation by making an exponential. Now, what you need to do from that is use your notes is that b to the x equals a, and log base b of a equals x. And I'm going to double check my notes real quick on page 67 just to verify that I have that correct. I suggest you do the same. It is correct. So now, here we have to identify what the b value, which in that case is 4. So 4 to the 7th is equal to x squared. Well, 4 to the 7th is 16,384 equals x squared. We're going to take the square root of both sides. But remember, square root is plus or minus. So x equals plus 128 and x equals negative 128. All right, and let's go ahead and check that using our calculator. So let's check x equals 128 first. So log base 4 of 128 squared equals 7. So 7 equals 7. So this checks. Now let's check x equals negative 128. Now, real simple. I'm going to highlight, enter, but now a negative number squared is in parentheses. So parentheses negative 128 squared is 7. So 7 equals 7. So these check. Okay, let's take a look at example 9. So this would be 3 squared equals x minus 5. So then that's 9 equals x minus 5. Add 5 to both sides, x equals 14. So let's check x equals 14. So again, use the calculator. Control log base 3 of 14 minus 5 equals 2. So 2 equals 2, so this checks. Let's take a look at last example, example 10. Okay, so then we have 2 to the 4th power equals 3x plus 5. Well, 2 to the 4th power is 16. So 16 equals 3x plus 5. Subtract 5 from both sides. We have 11 equals 3x. Divide both sides by 3. X equals 11 divided by 3. Okay, so let's check. X equals 11 divided by 3. So again, we're going to utilize our calculator. So control log base 2 of 3 times 11 divided by 3 plus 5 is 4. 4 equals 4. This checks. Go ahead and finish up your examples and start working on your assignment, and have a wonderful Wildcat day.